Hello, Algebra 1. This is lesson 98, distance between 2 points and slope formula. If you will look at your top of your notes, you're going to find two formulas that should look familiar. Although we haven't used the distance formula a whole lot this year, it is one that you should have seen before. It is not exactly pretty, but it is the square root of the x value subtracted and squared plus the y value subtracted and squared. One that should look a little more familiar to you is the slope equation, especially written here on the right side, where we have the difference of y over the difference of x. We're going to be utilizing both of those formulas for our lesson today. So the first thing is to go to that star question. And I'm going to go ahead and label on this star question when we're finding the distance between these 2 points. The first set of points I'm going to call x1, y1, meaning first x, first y. And the second set, x2, y2, meaning second x, second y. Then I can just take those and plug them into the distance formula given above. So the distance is equal to the square root of the second x value, -1, minus the first x value, 3, and then we square that, plus the second y value, which is 2, minus the first y value, which is -5, and we square that. Then we take this whole thing as a square root. So that is the setup of the formula. Now we're going to go through and simplify. We'll start by simplifying inside the parentheses. So -1 minus 3, that would become -4 squared, plus the next set of parentheses, 2 minus a -5. That is a sword fight. It will become a 2 plus 5, and that is 7 squared. Again, this is a square root up on top. Go back and now do the squaring of each parentheses. So -4 squared would become a positive 16, plus the 7 squared would become a positive 49, keeping that still underneath, a square root symbol. Let me fix that up real fast. A little technical difficulty. Now we're going to add 16 plus 49, and you should get distance is equal to the square root of 65. Okay, 65 can't be broken down anymore. There are no perfect squares that go into 65, so that is our solution as is. Moving over to question 2, find the slope of the line that passes through 3, -5, and again I can label that the first x and the first y, and -1, 2, which is the second x and the second y. Starting off with slope, I have a lowercase m for slope, and it equals the change in y over the change in x. If you haven't seen that before, the triangles need change when we do math and science upper level classes. We also call it delta. So delta y over delta x means change in y, change in x. Rewritten then using these values from the problem number 2, you're going to find your second y value, subtract your first y value, and put that over your second x value, subtract your first x value. Okay, so then simplified, on top I have 2 minus a -5. That's going to be a sword fight, and it's going to come out 7 over -4. And then because we want to use proper math, we take that negative out of our denominator, and we're going to rewrite it as the slope is equal to a -7/4. Just bring that negative out in front, and you're done with that one. Okay? Now we're going to move to your textbook to do the ABC questions. This is on page 414. Find the distance between these 2 points. Okay, so we're finding the distance, and the points are 4, -2, -4, -4. Now I'm going to go ahead and title these x1, y1, x2, y2. Okay, and remember, if you need to see that formula one more time, that we have the x values subtracted, and then we have the y values subtracted. All of it square rooted. So plugging in from these values, the second x would be -4, subtract the first x, and that is 4. We're going to square that, plus the second y, -4, subtract the first y, minus a -2. Okay, now we're going to go back and simplify inside the parentheses. The first set of parentheses, -4 minus 4, that's going to be a -8 squared, plus -4 plus 2, that's going to be a -2 squared. And then let's go ahead and simplify that. So -8 squared would become 64, and -2 squared would become 4. So I end up with the square root of 68. Now 68 does have a perfect square that multiplies into it. 4 goes into it. So I'm going to break this down in order to simplify it. This is the same thing as the square root of 4 times the square root of 17. And since square root 4 is a perfect square, it's allowed to come out. It comes out as a 2. Okay, so my final answer is actually 2 square root 17. All right, that's it for question A. Let's look at question B. We're going to find the slope when we are given 2 points. Okay, so we're finding the slope of these points, -4, -7, -8, -3. All right, so remember for slope, it's the change in y over the change in x. So we take our second y value, which is -3, subtract the first y value, minus a -7. X values do the same, second x minus the first x. Lots of stuff to simplify. It looks like we have some sword fights. Really, we could just call that -3 plus 7 over -8 plus 4. And then simplifying it again, we would get 4 over a -4. That's going to reduce down to a -1. Okay, so that's it for question B. Let's try question C, which is also a slope question. Slope for these points, 4, 7, and -14, -12. When we find slope, we call that lowercase m. We're doing the change in y over the change in x. Okay, so in this case, the second y is -12 minus the first y, 7, over the second x minus the first x. Okay, and we go through and simplify that. My numerator should be -19. My denominator is -18. The negatives are going to cancel, but I can't really do any other reducing, so I get 19 over 18 for my slope. All right. Now this homework is from your textbook, so let's scoot on over to question 10 and do that one together. Okay, question 10 from the homework. You are finding parts A and B, the slope and the distance between the given points. So let's start off with those given points. We have a -4, -4, 5, and then 2, 3. Okay, so part A is to find slope, which is change in y over change in x. All right, so for part A, I get the slope is equal to the second y, 3, minus the first y, 5, over second x, 2, minus the first x, -4. Simplify that, and I get a -2 on top, 2 plus 4 on bottom, which is 6. So final step of simplifying, reduce by 2's, and I get the slope is equal to -1/3. Okay, that's it for A. Now we have B. We're going to use the same points, but we're going to find the distance. Okay, so to find the distance, remember it's the big square root. And remember that we are going to start off with our x values subtracted. So we have 2 minus a -4 squared plus the y value subtracted, 3 minus 5 squared. Going back to simplify in each of those, parentheses 2 minus a negative 4, that's going to be really adding. So I get 6 squared plus negative 2 squared. And then go back and square each of those. 6 squared is 36. 2 squared is 4. Negative goes away. I get d equals the square root of 40. I cannot stop there though because that can be broken down. There's a perfect square 4 that multiplies into that. Okay, so to rewrite that, I want you to think of it as the square root of 4 times the square root of 10. And the square root of 4 comes out as positive 2 square root 10. So my final answer is 2 root 10 for the distance. All right, we're going to move over to 11, which is going to be a very similar question. We're going to find part A slope, part B distance. Our values to start with, negative 4, comma, negative 2, and then 4, comma, negative 6. Okay, part A is to find the slope. So we remember that's represented by a lowercase m. It's the change in y over the change in x. We do our y values, negative 6 minus a negative 2, over the x values, 4 minus a negative 4. When I simplify that, I get negative 6 plus 2, so that would be negative 4, over 4 minus a negative 4, that is 8. So further step of simplifying by 4s, I get negative 1/2 for my slope. Okay, and then we're going to go back to part B, which is to find the distance. All right, and once again, we're going to first do the x values subtracted. So in this case, it would be the second x minus the first x squared plus the second y minus the first y squared. Simplify inside those parentheses. 4 minus a negative 4 is actually going to be 8 squared. Negative 6 minus a negative 2 is really negative 6 plus 2. So that's going to become negative 4 squared. Simplify those squares. 8 squared is 64 plus negative 4 squared is 16. And then add those together. 64 plus 16 is equal to 80. So we have the square root of 80. Now we are going to be able to break that down. Okay, the perfect square 4 goes into it, and actually the perfect square 16 goes into 80. So I'm going to break that down into the square root of 16 times the square root of 5. Square root 16 comes out as 4, square root 5. So my final answer is D equals 4 root 5. All right, that's it for that lesson. Good luck.